Hi guys, my name is Jahana Amir and I'll be going over Lab 2, Lines of Charge. In this lab, we were to determine how two charged objects interact with other neutral and charged objects and with each other. Pieces of tape was used to record these interactions and to find the charge Q needed to make a suspended piece of U tape float above another charged piece of tape at a measured distance. This lab is a continuation of Lab 1, but the difference is the tape is not assumed to be a point charge, but rather a line charge. The same fundamental equations were used, but the fundamental principles and models were a little different from what we saw in Lab 1. So polarization, which is basically the result of a certain electromagnetic radiations when a neutral object interacts with a charged object, causing the neutral one to be polarized through a temporary dipole. We also use Coulomb's law, which relates to opposite charges attract and like charged repel. We also use the electric fields of distributed charges, where we divide the charged objects into a series of point charges. We find the electric field, we sum them up, and also the superposition principle. We also made similar assumptions in this lab like we did in Lab 1, with the difference that the both tapes are not treated as point charges. Other than that, both tapes have equal charges. We can say that the charges are equally distributed. We ignore air resistance and all other forces besides gravity and electric force. So a similar experimental procedure and observations was used. The two pieces of U-tape repelled each other. The U-tape attracted to neutral objects like the book, hand, the desk. This is due to the induced dipoles from the U-tape's electric field. The U-tape attracted to negatively charged objects. The paint after it was rubbed in my hair. The U-tape is positively charged and creates a negatively induced dipole when in contact with neutral objects. So these are some of the calculations I found out. Obviously, the gravitational force and the electric force is the same. The length of tape was 0.21 meters. Mass of tape, 0.0002 kg. The floating tape, 0.011 meter. The charge by treating it as a point charge, which is 1.4 times 10 to the negative 9 coulombs, and the charge found by line charge model, which was 5.4 times 10 to the negative 9 coulombs. So these are the computational model that I found out. So we started off by using the initial conditions from Lab 1 with previous charge calculations using a point charge. And then we use the function to find electric field using charge, change in position, magnitude of R and R hat. And then we moved on to using finding out the function used to find the line charge by creating line segment intervals along the axis. And the last two steps were to calculate the electric field and force by adding up each calculated charge from the previous charges to find the line of charge for the tape. And lastly, over here, we did the arrows to show the net electric force and the gravitational force. You can see my diagram to the bottom right, which where I found out the magnitude of electric force to be 1.96 times 10 to the negative 3 newtons, and the magnitude of gravitational force to be the same 1.96 times 10 to the negative 3 newtons. So to finish off the lab, we were asked a couple of questions. So what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So if we were to measure it as a point charge, I would have probably gotten the same value that I got in Lab 1. For Lab 1, the charge was 1.4 times 10 to the negative 9 coulombs, and that is opposed to by more accurate value based on the continuous charge model that I saw for Lab 2, which was 5.4 times 10 to the negative 9 coulombs. So this is because the line charge was larger than the point charge. And the second question was, why do these estimates differ? which value is more likely to be closer to the real value and why. I said that the estimates differ due to different methods of calculation. The line charge method has a more accurate model as it includes both an x and y component when describing the force on the top tape by the bottom tape. On the other hand, the point method is only calculated and modeled with a y component, so the line charge formula is more accurate because it includes the summation of many pieces instead of just one point. Thank you so much for watching, and I hope you have a great day.